Happy morning, children. We will start with practice set 2.2. First question, show that 4 root 2 is an irrational number. So we are using what is called as indirect proof, which you have studied in geometry, where we will first assume that, suppose that the given number is a rational number. Yes, we have to prove it's an irrational number, but we will assume for the present that it's a rational number. So 4 root 2 is a rational number. I am assuming it. So if it's a rational number, every rational number can be written in the form P upon Q that we have already studied, where P and Q are integers. P comma Q are integers, and very important, the denominator Q should not be equal to 0. So this way you can write. Now what we can do? Root 2 is equal to P upon 4Q. This 4 we can take it here in the denominator. You will get P upon 4Q. Now if you see P upon 4Q, P is an integer, 4 is an integer, Q is an integer. So multiplication of two integers will give you integers. So P upon 4Q is also a rational number. But you all have studied P upon Q is a rational number. P upon 4Q is a rational number. But root 2 is a irrational number. Correct? Now how is this possible that a rational number is equal to irrational number? Root 2, root 3, root 5, root 7, root 11, root 13. These are all irrational number. So if this is rational, then how can the value of rational number be equal to root 2? Correct? So what I assumed that 4 root 2 is a rational number is wrong. So this is an equation, right? Where we are saying that rational number is equal to root 2. But rational number cannot be root 2. Root 2 is an irrational number. So what we assumed was actually wrong, right? So what we will do what I said, we will do the explanation, where we will write the above equation. The above equation shows that root 2 is a rational number. Correct? Because P upon 4Q is a rational number. So it is telling us that root 2 is also a rational number. Correct? So is a rational number, which is not possible because root 2 is a irrational number, which is not possible because root 2 is a irrational number. So what supposition we did? Our supposition, suppose I wrote no, our supposition is wrong. That's simple, the sum is. Our supposition that 4 root 2 is a rational number is wrong. Therefore, 4 root 2 is an irrational number. So this way, in a very simple way, you can solve this example. Now, for the second example which has been given to you, the same method has to be applied. See here, practice set 2.2, the second example. Prove that 3 plus root 5 is an irrational number. So same steps are exactly the same. What you need to do here is like this. Same step, second question. I will just show it to you how it should be done. So here, show that 3 plus root 5 is an irrational number. So the same step how we did it, we have to follow that. Suppose 3 plus root 5 is a rational number. Same method it is. So now, if it's a rational number, every rational number can be written in the form P upon Q, where P and Q are, P comma Q are integers and Q is not equal to 0. So now what we will do, root 5 we will keep it to LHS and P upon Q minus, here it is no sign means plus sign. Take it to RHS, you will get P upon Q minus 3. If you want, you can just write it in P up Q form by taking the root 5 is equal to, here P minus, by taking the LCM. I hope you can understand this. P minus 3Q upon Q. So, here P minus P is an integer, Q is an integer, P minus 3 is an integer, P minus 3Q an integer, Q is an integer. So, this is a rational number. But root 5, I told you, square root of 2, square root of 3, square root of 5, square root of 7. These all we have already discussed. They are all irrational number. So, if you look at this equation, this is irrational and this is rational. Is this possible? So, this equation which we have written is actually not possible because this is rational, this is irrational. How can rational number be equal to irrational number? The values. So, what we have assumed, our supposition is wrong. Means it is, the other word is used is contradictory. That word can be used. So, we will write the above equation shows that root 5 is, see what you are saying, this is rational number. So, I want to prove 3 plus root 5 is an irrational number, correct? So, now I will write the above equation shows that root 5 is a rational number, correct? Because this is rational, is a rational number. This is contradictory. Different ways we can use to write. This is contradictory. So our assumption, what we had assumed, that in itself is wrong. That we can say. This is contradictory. Therefore, our supposition that 3 plus root 5 is a rational number is wrong, is incorrect. Is a rational number is wrong. Therefore, so any number, if it's asked in exam, only the values will be changing. I may give now, instead of 3 plus root 5 in paper, 3 plus root 7 I will give. The method remains the same. Therefore, 3 plus root 5 is an irrational number. This way you have to solve.